So now we're going to start to look at equations and writing them in a more general form so that we can read information from them. So in this lesson, we're going to be writing equations in 8 times b to the t form. So first off here in this column, we have equations. Some of them we'll recognize, some of them we won't, and we're going to put them in the basic form where there's just one simple coefficient, a base, and a t for an exponent. So looking at the first one, basically here, whenever I have multiplication in the exponent, which is kind of the situation we can make them into on each one, we can use this property. So if I have x squared to the third power, we know that we multiply those exponents. So this is x to the sixth. So if we see something with multiplication in the exponent, we could take it backwards and split it up. And then actually, if this was a number here instead of an x, we could evaluate this expression just to the third power. So when we have this situation, I'm actually going to rewrite the equation over here. I can actually take this 12 times t and just evaluate this and put that t on the outside. Okay, so to get that, a is already here, right? And we can type this in to get b. So I'm not going to get out the calculator. This is, pretty simple to type stuff in. So here on this, if I did type that in, and in my directions, I'm rounding to the nearest thousand for b, okay? And then the next step will go to nearest tenth of a percent. So if I type this in my calculator, this comes out to 1.062 to the t. So this is a times b to the t form. So now over here, we want to write the percent growth or decay per unit of time t. So we're not on these, we're not talking about is it days, is it months, is it years, right? We're just some unit of time. So in order to do that, I look at my base. My base is bigger than 1, right? So I know that it's growth. And to see how much growth, I just see how far away this number is from 1. And then I change it to a percent. So I move my decimal over 2. So that's 6.2% growth per whatever time unit we're using. Now for this, the next one, this is very similar. We just have e, but we do still have multiplication on the exponent. So basically I can just raise e to the 0.05 and put the t on the outside. So if I was going to type in this, we would end up getting this equation rewritten as 425 times 1.051 to the t. So looking at our base, we have growth again, right? So we find the difference from 1. And this decimal represents 5.1% growth. Now, looking at these two equations, those aren't really surprising to me because this one is set up for 6% compounded monthly, right? That's the type of formula we have. So I expect because of the compounding, this percent is going to just be a little higher than 6%. Same deal with this one, we have 5% growing continuously, so I expect to get a little bit more of a growth out of that continuous growth, and we see that in both of these answers. So looking at the next one, this one I can tell is a half-life formula, and we have a half-life of 12 time units, maybe 12 years, but if you ask me like how much is that changing per year, I probably couldn't give you a very accurate guess. So writing this in that form is definitely helpful. Now, we do need to talk about what we do with division. Basically, we're just going to write division as multiplication. So if that's t over 12, that can be rewritten as 1/12 t, because this is a 1t over 12. Now it looks kind of like the letter H, but you guys get the idea. So I put the 1/12 in the front, and now I can write it in that form. So I am going to write some work for this one just because this is a new type of problem. So this is to the 1/12, and then I'm going to put the t on the outside. So this is what I'm evaluating to get that value of b. So if I type that in my calculator, this evaluates to 0.944 to the t. I'm not surprised to see it's less than 1, right? Because this is half-life, so stuff is decreasing. So to find out the rate of decay, I'm still going to find the difference from 1, but because the number is smaller than 1, I'm going to put the 1 first when I subtract. This gives me 0.056. So each time unit, let's say it's years, we lose 5.6% of that substance. So 5.6% decay. So we're going to look at one more, and then I want you guys to just kind of like try the rest on your own to make sure you get it. This equation is a little different because it looks like I don't have an a value, I only have one number there. So that means that it's an implied 1, right? If nothing's there, it's times 1. So this equation is really 1 times 3 to the negative 4t. So once we write it like that, it's pretty obvious that this is what we're going to type in, right? So if I did type that in, 3 to the negative 4 is 1 over 81, right? So that's going to be a pretty small decimal. It ends up to the nearest thousandth being 0.012. So this is pretty significant decay, right? When I subtract this number from 1, I get 0.988. So this is 98.8%, almost all of it, right? A really significant decay per time unit. That is not something that I readily can see looking at this equation, and once again, that's why we're converting these all to the same form. So I'm going to suggest that you pause the video right now, try these last 3 on your own, and then come back and check the answers with me. Okay, so hopefully you tried them. On each of them, I'm just going to write down what I would type in my calculator. So that's what I would use for the base. Here, I'm going to make this a 1 and put the t at the end. That's what I would use. And here I have this crazy, get rid of t, crazy base to type in. Okay, so if I do that for each of them, I'm just kind of going down the column here. This one is 6 times 5.860 to the t. This one is 500 times 1.036 to the t. And this one is really slight decay because it's 0.999 to the t for that base to the t at that part. So my first one is really fast growth. Like we talk about when things double, we have a 2 right here. Triple would be a 3. So this is almost up to a 6 there. Just so to see what percent we're growing by, we still need to subtract 1. So that's not 4.86% growth, that's 486% growth once I move that decimal over. On my next one, we have 1.036 minus 1, so it's 0.036, so 3.6% growth. And then my last one, 1 minus 0.999 is 0.001, so that is 0.1% growth. Just be careful when the decimals are kind of different, like this one is really small, that you still move the decimal over 2 and you kind of keep those same rules.